this video, we'll cover the concept of introduction to structured programming. We will start with the definition of terms in structured programming. We will start with programming. Programming is the process of developing computer instructions used to solve a particular task using a programming language. What is programming language? A programming language is a set of symbols that can be translated into machine readable form by the computer when arranged in a given syntax. What is syntax? Syntax is a sequence or order of writing set of characters or symbols in a programming language to perform a given task. What is structured programming? It is a style of programming that is based on use of control structures. Some programs had the intention to create computer instruction. What is a source program? This is the program code entered by the programmer in programming language editor's window that is yet to be translated into machine readable form. What is object code? This is the program code that is in machine readable form. What are translators? These are language processors that convert source code to program object code. These translators include assemblers, interpreters, and compilers. Let me take you through the translators. What is an assembler? This is a language processor that translates assembly language into machine language for a computer to understand and execute. On the other hand, an interpreter is a language processor that translates the source code program line by line, allowing the CPU to execute one line before translating the next line. This method of translation was used by the early computers that did not have enough memory to store the object as a file. What is a compiler? A compiler, on the other hand, translates the entire source program into object code file that can be made executable by linking. The executable can be installed on other computers to perform the task programmed. Examples of structured programming languages include C, Pascal, COBOL, which is Common Business Oriented Language, Fortran, which is Formula Translator, ADA, and BASIC, which is Beginner's All-Purpose Instructional Code. I'll also take you through the history of programming languages. There are two levels of programming languages, which include low level and high level programming languages. Low level programming languages are languages that require less or no translation for a computer to understand. That is, they are already or almost in machine language. They are hardware oriented hence not portable. A program written in low-level language for one computer cannot be used on another computers. These languages include machine languages, which is also called the first generation language. This is a programming language where program instructions are written using binary digits or bits. It is given data and instruction which are in binary form. Many constraints are needed to accomplish a simple tasks. Another low-level language include the second generation languages or the assembly languages. These are programming languages whose instructions are written in mnemonics, which are symbolic operation codes composed of two or more ones. For instance, MOV EX, 15 AC, which means move 15 to register EX. We have SUB AX, 10. It means you are giving a command to subtract 10 from the value in AX. Assembly languages overcame understanding and use of machine languages since they are readable. However, they require an assembler to translate them into machine language for a computer to understand. The other level of languages include the high-level languages. These languages are languages whose instructions are English-like, can be read and understood by non-programmers. They are machine independent, and therefore the program is more concerned with the problem other than how machine operates. They include the third generation languages, also known as structured or procedural languages. They emphasize the breaking of a program into smaller units, which include Pascal, COBOL, Basic C, Fortran, and ANA. We also have the fourth generation programming languages. They present the programmer with graphic tools such as buttons, fonts, and other tools for easier interface design. Unlike the third generation languages, where programmer has to come with all code, everything from scratch, they allow programmer to select graphical objects and use them to design on this form. They include Microsoft Visual Basic, Visual COBOL, and DeFi Pascal. We have the fifth generation programming languages. These are languages that use artificial intelligence that enable computer to depict human-like intelligence. These include Prolog, Mercury, Lisp programming, and Occam. We'll cover the concept of programming paradigms. What are programming paradigms? These are ways in which programming languages are classified. A given language is not limited to a given paradigm. For instance, Java supports elements of procedural, object-oriented, and event-driven paradigms. These paradigms include monolithic programming, in which all the code designed in a single large blocks. They do not support splitting of long program into either functions, subroutines, or methods to perform a particular task. The other paradigm is structured programming, which emphasizes on use of control structures, programs, subprograms, and indentation in writing program codes. They do not allow use of go-to statements to change the course of program execution. These languages include Pascal, C, COBOL, BASIC, and other. The other paradigm is object-oriented, in which programmer designs both data structures and operations applied to data structures. The pairing of data structures and the operations that can be performed on them is known as an object. A program therefore becomes a collection of copulating objects rather than a list of instructions. These languages include Java, C++, C#, and Python. We have the other paradigm, which is visual programming, where programmers create by manipulating program elements graphically rather than textually. This programming frees programmer from having to write code but provide graphical objects to be used to create interfaces instead. These languages include Microsoft Visual Basic, Visual C#, Visual COBOL. The other paradigm is internet-based programming. This is where the programmer creates web-based applications. Since HTML is the basic design languages to enhance HTML and web application to support the dynamic web requirements, server-side and client-side programming languages are used. The languages include JavaScript, Java, PHP, Perl, Python, and ESP. Next, we'll cover the stages in the program development cycle. There are several stages of program development. The first stage includes program recognitions. This is the understanding and interpretation of a particular program. To identify a program, look for keywords such as compute, evaluate, compare, calculate, and etc., and rewrite the program in a simplified way using keywords. For instance, a mathematical program for calculating the area of a circle is written as area A is equals to pi times square of r, which is the radius. The second stage is problem definition or analysis. This is when the programmer defines the likely output, input, and the processing activities using keywords outlined at the problem recognition stage. This stage outlines a clear view of what the program should produce, methods that can be used to solve the problem, and the best alternative chosen. For instance, our problem area is equals to pi r squared has the following steps. Input. We input the radius of the circle. Process. we calculate the area of the circle, which is pi multiplied by radius multiplied by radius. Our output is equals to area of the circle, which is the product of the area, pi times radius times radius times radius. The other stage is the program design. This is the stage in which the programmer decides how the various goals of the program are to be achieved. It shows the logical steps a program follows in order to solve a problem. The program must analyze specification and decide whether the program is monolithic or modular. The next stage is program coding, which involves converting program design into its equivalent program using a programming languages. This stage results into source code program that can be translated into machine readable form. The next stage is program testing and debugging, where a program writes program. It is clear that the code written must be perfect, so the program has to be tested to ensure it yields expected outputs, detect errors, and debug or correct the errors. There are two types of errors encountered during testing of a program, which include syntax errors, which are errors that emanate from improper use of programming language rules, which include grammatical mistakes, missing or misuse of punctuation marks, improper naming of variables, misspelling of user-defined and reserved words. This is debugged before learning the program. The other type of error is logical errors, which are also known as runtime errors. They are not detected by translator, but the program gives wrong outputs. There are several methods of detecting errors in a program, which include the following. We have desk checking. This is going through a program while still on paper before entering it into a programming language editor's windows, which help to detect syntax and logical errors. There is the use of debugging utilities. This involves the use of translators to detect syntax errors in a program already in programming languages editor's window. Most of the programming languages have integrated development environment with compiler that detects syntax errors, outrun them, and allow the programmer to correct them before execution. Here's the use of text data. This is carrying out runs of a new program before by entering data variation and extremes or data with errors to see whether the program will halt or crash. The other stage of program development is implementation and maintenance. This is the action, delivery, and installation of a new program ready for use. Training of staff on the program use is also done. The implemented program is then reviewed in case specifications are not met and maintained. The next stage after implementation is maintenance, which is an ongoing activity of evaluating, implementing program to see whether it is performing as expected. Errors and shortcomings detected are corrected. We then cover the concept of program documentations, which is the writing of support information explaining how the program can be used, installed, maintained, and modified. All stages of program development should be well documented. Documentation can be in several ways, which include internal documentation, which are non-executable lines, which are called comments in a source program that enable programmer to understand code statements. Internal documentation is part and parcel of source program codes. These codes are normally included in the codes of the source program. We have external documentation. These are reference materials for users, operators, programmers, printed as booklets. They specify users' manuals, installation manuals, and programmers' manuals. There are 3 target groups for any documentations. These groups include user-oriented documentations. These are reference materials that enable user to learn how to use program with little help from program developer. We have also operator-oriented documentation. These are reference materials for technical staff. It provides outline of how to install and maintain the program. We also have the program-oriented documentation. This is the documentation that provides technical information for the future modification of the program. All program need modification or review to improve their performance to suit the changing environment and technology. That is the end of our topic. Let's meet next time.